Hey everybody, it's Savannah Rodriguez. I'm gonna teach you guys how to do Riemann sum, both left and right, upper and lower Riemann sum for this particular one. So let's get started. So before we look at even the graph, we're gonna go ahead and just use the general formula for writing a function. So that's gonna start at ax to the third plus bx squared plus cx plus d. So now we see here that the only variables that aren't x are a, b, c, and d. And so that's kind of what I used to do this over here. I did little sliders for a, b, c, and d, so you could actually use this to calculate any function. So once we calculated, I just went ahead and started. So I picked 1. So the 0 is just, the a is just 0. The b is actually 1. So since that's 0, since this is 0, that's all just canceled out, and that's 1, so it's just going to be, I'll do that in blue, it's just going to be x squared. And then this c is 0, so that all cancels out, and then this d is 2, so that's just plus 2. So that's our function, but we're going to have to integrate that because we're actually finding the area under the curve, which is actually essentially just an integral. So we would just do an integral right above that, and we see here that I chose to do it. Now you can choose to do it from wherever to wherever. You just zoom out more and more and more, and you can keep going forever. But I chose to just go to 3 for simple calculations. So I just do from 0 to 3. So from 0 to 3, we're doing the integral of x squared plus 2. But this is just an approximation because we're doing Riemann sum, left and right, so this is not exactly. Okay, so we'll do left first. So we will make left bread. So left Riemann sum, we'll do this. And so we can see that our first square, left Riemann sum, would also be lower Riemann sum. So we know it's left because it touches the graph on the left line, not the right line. So on the left line. So this would be at 0. Our base is 0.5 and our height is 2. Now, if you're curious as to how exactly you get that point, it's kind of easy to tell here, but as you go on, it's obviously harder and it's harder to see. All you have to do is just plug in your x value into the equation so that you can get it, and so I went ahead and did that. Once you plug in 0.5, you do indeed get 2. And so then the next one, a little hint, they are all going to be, let me fix that. They are all going to be 0.5 because we actually have 0 to 3, and so we're just gonna, since we have 6 intervals, that's just 6 in half, is 3. So the next one is gonna be plugging in 0.5 to the equation. So it'll be this actual second box. So it'll be 0.5, and when we plug in 0.5, I went ahead and done that for you. That's just 2.25. And then the next one is still 0.5. And so that next box is actually when you plug in 1 into the equation, and that's actually when you get 3. The next one is also 0.5. Now we want to make sure that we have 6 of these. 1, 2, 3, 4. So we're on our 4th box. So we go 1, 2, 3, 4. We're on this box. So we have 0.5 still on the bottom. As we can see, all the bottoms are equal. And so when this is actually when we plug in 2.5, or actually, this is when we plug in 1.5. 1.5, we get 4.25 into the equation. And then when we plug in 2, we get 6. And when we plug in 2.5, we get 8.25. And again, you can see all these values over here. This is just when we're plugging in the different coordinates. This is when we plug in 2.5, so on and so forth. Now, the reason that we plug in 2.5 and not 3, and the reason that we don't go to 3, besides the fact that we only have 6, is also the fact that we are only going to use this height. We aren't using this height. See, if we were to measure this height, that would be when we do upper sum. Or right. So we're doing left, so we stopped there, and so I just went ahead and plugged all those values into the calculator just as you see them, and that will actually equal 12.5 12.875, and which I was rounded to just 12.88. And now if you wanted to check that, you would just come over here and you would see that we actually have 12.88 as a lower sum. And so that's a way to check that. So that's us doing it with lower sum or left Riemann sum. And so if we do it with right Riemann sum, it's obviously a totally different number. So let's go ahead and try that one out. So I'll just go ahead and erase all this for now. Now it is a difference because, as you can see, one is an over approximation and one is an under approximation. As you can tell, the under approximation is the lower sum or left Riemann sum, and so we just calculated that one, and so now we'll go ahead and do the upper sum. So the upper sum, which is right Riemann sum, is, now we can see we have the same sizes. The only thing that changes is the heights. So the bases are all going to be 0.5. And again, we are still only going to have 6 intervals or 6 different ones. So we'll do 0.5, and once we plug in 0.5, we get 2.25. Now that's when you plug in 0.5. Now for this one, we are actually not plugging in 0 as we did for the other one, because we're taking the right value. We're not taking 0, we're actually taking this value, which is 0.5. Oops. This next one is also again 0.5, like I stated before, they will all be 0.5. And this is 3. And then the next one is 0.5 again, because they're all equal bases. 4.25 plus 0.5 again, which is 6. And again, this is all just plugging them in. So it's 0.5, 1. This is when you plug in 1.5. This is when you plug in 2. Let's fix that one. Oh. Okay. And then when you plug in 2.5 is 8.25. And then when you plug in 3. Now in the last one we didn't plug in 3, but this one we do, so it's just 0.5. Oops, let me fix that. I don't know why this is going so crazy. And so when you plug in 3, it's actually 11 into it. So it would just be 3 squared, which is 9 plus 2, because we're plugging it into this equation. And so it's 11. That's actually how you find all of these heights. And so when you go ahead and do this one, we'll see that we get 17.3. Oops. Don't know what happened there. Let's go ahead and clean that up. 17.375, which is just rounded to 17.38. 38. And actually, if we check that over here, we can see that it's 17.38 over here. So it's actually how you find left and right Riemann sum. There's also a midpoint, which you can do the same way. It's just that you would just cut these in half, these bases. Same heights though for all of them. But actually another way, now that we have both of our upper sum and the lower sums, we can actually find it by just subtracting the two, because that's just the difference. And so it would actually just end up being 4.5 if you subtracted both of them. So that's how you find lower sum and upper sum, or right Riemann sum and left Riemann sum for this particular equation. And so yeah, I hope this video helped, and see you next time.